refraction of light. Refraction of light. Refraction of light. Next, the topic is refraction of light. Refraction of light. Like reflection, also refraction is another property of light. In reflection of light, in reflection of light, if this is the reflecting surface and this is the incident ray and this is the normal, this is the angle of incidence I, then this is the reflected ray with angle of reflection R. Here all the phenomenon occurs in a same medium. If this medium is air and this is the reflecting surface, the incident ray that moves or travels in air and after reflection again it changes its path and moves in air. That means there is no other medium is present, only all the phenomenon occurs in a single medium. But in refraction of light, here you have to take two different medium. That means here, like the medium is air and you have to take another medium, let this water or kerosene or anything in which light can move. Let this is medium 1 and this is medium 2. Two different mediums, and let this is the incident ray and this is the normal. N dash is normal to the interface. This is medium 1, this is medium 2, and the green line, that is the interface for the medium 1 and medium 2. Then here the incident light, that is in medium 2, and after refraction the ray of light will move to the second medium with changing its direction. That means after refraction of light, the ray of light will change its path. This is the refracted ray, and if there is no medium in same medium, then this is the path of the ray. As there is another medium present, that's why the ray of light change its direction. So we can say in refraction of light we require two different medium, and due to change in medium the ray of light change its path. This phenomenon is known as refraction of light. And here, like reflection of light, we can say this is the angle of incidence I and this is the angle of refraction R. That means the angle in between the normal to the incident ray is called the angle of incidence, and the angle between the normal to the refracted ray is known as angle of refraction. And here, like a reflection, there are also two laws for refraction of light. So the first law of refraction is, here this is the incident ray, this is the normal, and this is the refracted ray. So we can say the first law of refraction is the incident ray, the refracted ray, and the normal to the interface all lies in the same plane. So this is first law of refraction. Then there is another law, the second law of refraction. Here, in reflection of light, the law was I is equals to R. But here, the second law, that is sine of, in trigonometry, you know the function sine function, cosine function. So here we have to take the sine of the angle of incidence to the sine of angle of refraction is a constant. That means sine I divided by sine R is a constant. So what is that constant? That is the, if this is the first medium, so we can say with refractive index mu1. Let mu1, mu is the refractive index, and mu1, that is for medium 1. And we can take the refractive index for the second medium, that is mu2. And here the ray of light that travels from medium 1 to medium 2, and the formula sine I divided by sine R, that is a constant. So what is that constant? That is the refractive index of second medium with respect to first medium, that is mu21. Mu21 means that is refractive index of medium 2 with respect to refractive index of medium 1. Clear? So there is a term refractive index. What is refractive index? Okay, we will discuss it about refractive index. So first you have to remember mu21. Mu21, that is refractive index of medium 2 with respect to medium 1, that is mu2 divided by mu1, and mu1 2, that is refractive index of medium 1 with respect to medium 2, that is equals to mu1 divided by mu2. You have to remember here the ray of light that travels from medium 1 to medium 2. So the second law is sine I divided by sine R, that is a constant, that is mu21, that is mu2 divided by mu1, refractive index of second medium with respect to first medium. Also this law is known as Snell's law. Snell's law in refraction of light. So there is a term refractive index. What is refractive index? Refractive index, which is denoted by mu. So what is refractive index? Refractive index, remember, refractive index is the ratio of mu is equals to ratio of speed of light in vacuum to the speed of light in that medium. Suppose you have to find out the refractive index of water. Refractive index of water. So here you have to take the speed of light in vacuum, that is C, and let the speed of light in water, let this is V. So by using C and V you can find out the refractive index of water. So formula of refractive index is the speed of light in vacuum to the speed of light in that medium, for which we have to find out the refractive index. Like if you want to find out the refractive index of kerosene, then you have to take the speed of light in vacuum to the speed of light in kerosene. That will give you the refractive index of kerosene. And you know the speed of light in vacuum, C, that is 3 into 10 to the power 8 meter per second. So this term C divided by V will give you the refractive index of that material. And remember the medium for which mu is more, the refractive index is more, is known as denser medium. The medium for which the refractive index is more is known as denser medium, and the medium for which mu is less is known as rarer medium. Clear? And remember, when the ray of light travels from, suppose this is the rarer medium, this is denser medium, and the ray of light here, this is the incident ray with angle of incidence I, and this is the second medium, that is the denser medium, and here the ray of light that travels from the rarer to the denser medium. For that case, the ray of light will travel or move towards the normal. This will be the path of the ray R. Here I is more than R. Clear? When the ray of light travels from rarer to denser medium, then it moves towards the normal. And the another case, if medium 1 is denser, medium 2 is rarer, and the ray of light that travels from denser, angle of incidence I, for that case the ray of light will move away from the normal. Here I is less than R. That means when the ray of light travels from denser to rarer, it will move away from the normal, and when the ray of light travels from rarer to denser, it will move towards the normal. Clear? And remember, the optical density and the mass density, they are two different things. The medium for which the optical density is more is known as the denser medium, and for which the optical density is less is known as the rarer medium, and the mass density, that is a different thing, the mass per unit volume. Clear? Mass per unit volume. Suppose if we take mass density rho, that is mass per unit volume, and the refractive index, that is speed of light in vacuum to the speed of light in that medium. And if you take water and kerosene, among water and kerosene, remember the refractive index of kerosene is more than the refractive index of water. Mu K is more than mu water. Refractive index of kerosene is more than the refractive index of water. That means we can say kerosene is optically denser with compared to water, but the mass density of kerosene is less than the mass density of water. Clear? So mass density and optical density, they are two different things. Kerosene is optically denser but mass density is less. So these are two completely different things. So you have to remember what is refraction of light, the laws of refraction, then what is refractive index, and what is denser medium, what is rarer medium.